Okay, hello and welcome back, and we're going to continue learning about some new advanced integration techniques. Today's is tabular integration, which I think is a technique that's not often spoken about. I don't think many teachers teach this in school. I could be wrong about this, but it's not as popular as some of the other integration techniques. But you'll see that it saves you so much time. So this is a really exciting one. This is one that once I learned it, I never forgot it because it saved me so much time. Let's get into it, and it's super easy. That's what you'll like about it the most. So sometimes, as we've already seen, we may need to do integration by parts multiple times, which is fine. We'll get the correct answer, but it's long, it's messy, it's not very fun. So tabular integration is super handy technique that expedites the process of integration by parts and keeps things organized. And when I say expedite, I mean expedite. So the idea of how this works is we're going to choose a u and dv, just like we did with integration by parts. But now we just continuously take the derivative of the u term until we reach 0. And we continuously take the integral of the dv term the same amount of times. From there, we're going to follow a pattern of multiplying and alternating between adding and subtracting to get the final answer. And you're like, what in the world? This sounds much more complicated than integration by parts. But it's not. It really isn't. You don't even have to solve that many hard integrals. Let's see an example. You can see I'm super excited about this. So suppose we wanted to find the integral of x squared sine of 4x dx. I have faith that we can solve this using integration by parts, but I don't want to. I want to use tabular integration. So what I'm going to do is choose a u and dv. In this case, my u will be x squared, my dv will be sine of 4x. From there, we're going to continuously take the derivative of the u term. So we take the derivative of 2x, we get 2x. We take the derivative of 2x, we get 2. We take the derivative of 2, we get 0. Boom, we're done. Okay, so now on the dv side, we take the integral 3 times and whatnot. So let's do the first integral together. The integral of sine of 4x dx, we can use u substitution. Let's let u equal 4x, which means du equals 4 dx. Our integral changes to sine of u times du over 4. That's equal to 1/4 the integral of sine of u du, which is negative 1/4 cosine of u. U is 4x. So here we write negative 1/4 cosine of 4x. And then we take the integral again, and so now we take the integral of like negative 1/4 cosine of 4x. So I believe that is negative 1/16 sine of x, sine of 4x. And then once more to get 1/64 cosine of x. And if I'm wrong, well, they're right here, and I was correct. So we have this little chart here of these u's and dv's. Okay, so now we want to create our answer, and to do that, we're going to do this cross multiplication strategy in sort of like an adding subtracting pattern. Let's see what that looks like. So the cross multiplication is indicated by these arrows, where you go from the first term on the u side to the second term on the dv side. You multiply those two together, and you multiply that with positive 1. Then the second term is going to be the second u term times the third dv term, and that gets multiplied by negative 1. And then you follow the next arrow and multiply that with positive 1. So this positive 1 minus 1 alternates. And you can have many of those if this u list is longer. But in this case, it just goes positive 1, minus 1, positive 1. You always start with positive 1. So let's try computing all of that out. So positive 1 times x squared times negative 1/4 cosine of 4x gives us negative x squared over 4 cosine of 4x. Now we do the second term. Negative 1 times 2x times negative 1/16 sine of 4x. So that'll give us 1/8, or positive 1/8 sine of 4x. oh, there's also an x in there. So positive x over 8. So like now they're combined together, we're adding them together. And the last term, positive 1 times 2 times 1 over 64 cosine of 4x. So that will be plus 1 over 32 cosine of 4x. Don't forget your plus c. And in fact, that right there is your answer. We can check it out here. I wrote it here. That's it. That is your answer. That's all you had to do. Just create this chart, draw these arrows pointing downwards and to the right, and then alternate between the positive 1, minus 1, positive 1. Then multiply and combine like terms. That's all there is to it. Let's do a couple of examples and go through it. So we need to choose a u and a dv. But the main thing to note is that our u term, we're going to continuously take the derivative of it, and we want it to eventually get to 0. So here, an unwise choice for u would be e to the x, because the derivative of e to the x is e to the x, and then we take the derivative of that, and it's still e to the x, and we never reach 0. So that's why for tabular integration, it's nice when there's a polynomial term like this, because we know eventually down the line, when we take a bunch of derivatives, we'll get to 0. So we have a u and we have a dv. We'll let u equal x squared minus 1, and we'll let dv equal e to the x. Now we take the derivative of x squared minus 1, which is 2x. The derivative of 2x is 2. The derivative of 2 is 0. Now we switch to the dv side. The integral of e to the x is e to the x. The integral of e to the x is e to the x. The integral of e to the x is e to the x. Now we draw our arrows starting from the first u term to the second dv term, then from the second u term to the third dv term, and then from the third u term to the fourth dv term. We alternate between plus 1 and minus 1, so plus 1 for the start, minus 1 for the second, plus 1 for the third, and then multiply along those arrows. So the first term will be x squared minus 1 times positive 1 times e to the x. Then we're adding to that 2x times negative 1 times e to the x. And then we have 2 times positive 1 times e to the x. And all of this is being evaluated from 1 down to 0. Let's clean this up a little bit. So we get e to the x times x squared minus 1 minus 2x e to the x plus 2e to the x evaluated from 1 down to 0. Use our fundamental theorem of calculus, and we should get e times 0 minus 2 times 1 times e plus 2 times e minus e to the 0 times negative 1 minus 2 times 0 times e to the 0 plus 2 times e to the 0. This gives us 0 minus 2e plus 2e minus 1 minus 0 plus 2. So this gives us a final answer of negative 1. And see how much easier that was than doing integration by parts. All we had to do was take the integral of e to the x. That was the only integration we needed to do, and we solved the problem. That's why this is so cool. Let's do one more problem because, tabular integration can't be applied to every single problem, only some problems, but this problem will be a nice one. The integral of x squared sine of x dx. If you watched our integration by parts video, you might remember this question, where we solved this question and it was quite annoying because we had to do some integration by parts multiple times. So hopefully now it'll be a bit easier. Let's try doing tabular integration. We'll choose a u, we'll choose a dv. Again, we want our u to bottom out to 0, so choosing sine of x won't be great because that goes through that cycle of sine, cosine, negative cosine, sine, cosine, and so on. So let's let u equal x squared, and dv will equal sine of x. The derivative of x squared is 2x, the derivative of 2x is 2, the derivative of 2 is 0. We've reached 0. Now we take the integral of sine of x. The integral of sine of x is negative cosine of x. The integral of negative cosine of x is negative sine of x. And the integral of negative sine of x is cosine of x. From here, we can draw our arrows, starting from the first term, going to the second term, from the second to the third, and from the third to the fourth. And now we alternate between positive 1, negative 1, positive 1. And now combine them all together. So the first term will be x squared times positive 1 times negative cosine of x. We'll add to that 2x times negative 1 times negative sine of x. We add to that 2 times positive 1 times cosine of x. And then we'll tack on a plus c since the integral is indefinite. And simplify. Negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus c, and that is your answer. Look how easy and quick that was. It's a lot of fun. In both of these examples, we only had like 4 steps of this u and dv. You can have many, many more, so I'll give you a very quick example. We won't solve it all out, but if we had x to the 4th sine of x dx, then our u would start with x to the 4th, then we would go 4x cubed, 12x squared, 24x, 24, 0. On our dv side, we would have sine of x, we would have negative cosine of x, we would have negative sine of x, we would have cosine of x, we would have sine of x, we would have negative cosine of x. And again, you draw all of these arrows until you get to the very bottom. And again, alternate between your plus 1, minus 1, plus 1, minus 1, plus 1. And then you can get the same answer from there. But look how quick this was. It's so quick, and that's the specialty of tabular integration. I hope you like this technique as much as I do, and hopefully this will help you on your exams to solve questions even quicker. But yeah, thanks for tuning in, and as always, take care.